Today we will see unit exercises of lesson 1. Also, we will see some additional exercises and information on this lesson. Unit exercise. Question number 1. If the ordered pairs x square minus 3x, y square plus 4y and minus 2, 5 are equal, find x and y. Equating the first coordinates, this and this equated, we get x equal to 2 or x equal to 1. Equating the second coordinates, y square plus 4y equal to 5. Then y square plus 4y minus 5 equal to 0. Y square plus 5y minus y minus 5 equal to 0. Later you will learn solving quadratic equation. We need two numbers here such that their product is minus 5, sum is plus 4. Therefore, 5 and minus 1 will satisfy that. So, 4y is written as 5y minus y. From first two terms y is taken out, y into y plus 5. From second two terms, common term minus 1 is taken out. Minus 1 into y plus 5 equal to 0. Then y plus 5 into y minus 1 equal to 0. Y will be equal to minus 5 or y equal to 1. Answer is x equal to 2, 1, y equal to minus 5, 1. Question number 2 of unit exercise. The Cartesian product A cross A has 9 elements, among which minus 1, 0, 0, 1 are found. Find the set A. Since this is A cross A and number of elements 9, A will have 3 elements. Two ordered pairs are given. Here, first coordinates and second coordinates all are from set A only. Therefore, minus 1, 0, 1. 3 elements. Hence, this will form the set. Minus 1, 0, 1. Question number 3. Given that f of x equal to square root of x minus 1 when x is greater than or equal to 1, equal to 4 when x is less than 1. Find f of 0. This is multiple domain function. Now we need to find f of 0. F of 0 falls in the second domain interval. Hence, f of x is 4. F of 0 equal to 4. Find f of 3. 3 falls in the second domain interval. Therefore, f of 3 equal to square root of 3 minus 1 equal to square root of 2. Then find f of a plus 1 in terms of a, given that a greater than or equal to 0. If a is greater than or equal to 0, then a plus 1 is greater than or equal to 1. It falls in first interval. Therefore, a plus 1 falls in the first domain interval. F of a plus 1 equal to square root of a plus 1 minus 1. A plus 1 replaces x here. Therefore, equal to square root of a. Question number 4. Let a equal to 9, 10, 11, 12, 13, 14, 15, 16, 17 and let f is a into n be defined by f of n equal to the highest prime factor of n belonging to a. Write f as a set of ordered pairs and find the range of f. Here the elements are given from 9 to 17. The function is highest prime factor of this number. So first number 9. 9 is 3 into 3. Highest prime factor is 3. 10 is 2 into 5. Highest prime factor 5. Like that 11 HPF is 11. For 12 3. 13 13. 14 7. 15 5. 16 2. 17 17. Therefore, the function will contain the ordered pairs 9, 3, 10, 5, 11, 11 up to 17, 17. Range of f is therefore set of the second coordinates 2, 3, 5, 7, 11, 13, 17. Question number 5. Find the domain of the function f of x equal to square root of 1 plus square root of 1 minus square root of 1 minus x square. Here in the innermost square root, x square should be less than or equal to 1 here. Therefore, x square should be less than or equal to 1 or minus 1 less than or equal to x less than or equal to plus 1. Therefore, domain equal to domain interval -1, +1 shown within square bracket. Question number 6. Given that f of x equal to x square, g of x equal to 3x, h of x equal to x minus 2, prove that FOGOH equal to FOGOH. That is, here first two functions evaluated, then combined with third. Here last two evaluated first, combined with first function. First LHS equal to FOGOH, f of g then OH equal to f of 3x OH. This becomes equal to 3x whole square O x minus 2. Now x minus 2 will replace x in this. Therefore, we get this finally 9 into x minus 2 whole square. Coming to RHS, here last two are evaluated first. FOG of h, FOG of x minus 2 equal to FO 3 into x minus 2. 3 into x minus 2 will replace x in f of x. Again we get the same result. Therefore, LHS equal to RHS, hence the proof. Simply FOGOH is x square O 3x O x minus 2. Now x minus 2 will replace x in this. Then entire 3 into x minus 2 will replace x in left side. 3 into x minus 2 whole square. Question number 7. A equal to 1, 2, 2 elements. B equal to 1, 2, 3, 4, 4 elements. C equal to 5, 6, 2 elements. D equal to 5, 6, 7, 8, 4 elements. Verify whether A cross C is a subset of B cross D. From the sets, we can easily see A is subset of B. Then from C and D, we can easily find C is subset of D. Then combine 1 and 2. Either side of subset symbol, we take cross product. A cross C will be subset of B cross D. Now in terms of ordered pairs, A cross C will contain these elements. B cross D will contain these elements. This you can easily write. Since you are already very much familiar in writing the Cartesian products. Now we can see all the ordered pairs in A cross C are also occurring in B cross D. Therefore, A cross C is a subset of B cross D. Question number 8. The function f of x equal to x minus 1 by x plus 1, x not equal to minus 1. Show that f of x equal to minus 1 by x. F of x equal to f of x minus 1 by x plus 1. X is now replaced by x minus 1 by x plus 1. Then equal to x minus 1 by x plus 1 minus 1 by x minus 1 by x plus 1 minus 1. X minus 1 by x plus 1 plus 1. Simplifying, numerator x plus 1 minus within bracket x plus 1 by x plus 1. Denominator x minus 1 plus x plus 1 divided by x plus 1. Here itself we can cut the common divisor x plus 1 here. Same question continued. Numerator will be x minus 1 minus x plus 1 by x plus 1. Denominator x minus 1 plus x plus 1 by x plus 1. Bracket open. X and minus x will be nullified. So minus 2 by x plus 1. Here 2x by x plus 1. In numerator, divisor is x plus 1. In denominator, divisor is x plus 1. Therefore, they will get cancelled out. Minus 2 by 2x equal to minus 1 by x. Hence the proof. In unit exercise, question number 9. The functions f and g are defined by f of x equal to 6x plus 8. G of x equal to x minus 2 by 3. First subdivision, find g of 1 by 2. G of 1 by 2 will be g of 1 by 2 minus 2 by 3. Further simplifying, g of 1 minus 4 by 2 by 3 equal to g of minus 3 by 2 by 3 equal to minus 3 by 6 equal to g of minus 1 by 2. Again, in g of x, x will be replaced by minus 1 by 2. Further simplifying, we get minus 5 by 6. Find g of f of x in its simplest form. G of f of x equal to g of 6x plus 8 equal to 6x plus 8 minus 2 by 3 equal to 6x plus 6 by 3 equal to 2x plus 2 or 2 into x plus 1. Question number 10. Write the domain of the following real functions. F of x equal to 2x plus 1 by x minus 9. X can take up all real values except 9. Hence domain equal to r minus 9. Then p of x equal to minus 5 by 4x square plus 1. Domain r no restriction because denominator will not become 0 for any value of x. Q of x square root of 2 minus x. If x is greater than 2, this will become negative valued. For x greater than 2, the function becomes square root of negative number, which is not equal to real number. Hence the domain equal to x belonging to R, x less than or equal to 2. H of x equal to x plus 6. Here no restriction, hence the domain is R. Let us see some additional questions. Question number 1. Indicate graphically the Cartesian product of A belonging to R and in interval 2, 3 and B belonging to R in interval 3, 5. Question number 2. Set A equal to set of x such that x square greater than 4, x less than 2, x belonging to n. B equal to 3, 4. Find n of A cross B. Then question number 3. The blue colored line or blue shaded area in the graphs show A cross B. Write down any 5 ordered pairs of the Cartesian products. Question number 4. Write any 5 ordered pairs of Q dash cross Q. Question number 5. Write any 5 ordered pairs of Z cross Z. Answer for the first question. Set A is the number interval 2, 3. Then set B is 3, 5. 3 to 5. Hence, this is x equal to 2 line, x equal to 3 line, y equal to 3 line, y equal to 5 line. The intersecting points, 4 points that form the vertices of the rectangular region. Shading them blue, we will get the A cross B. The shaded region contains ordered pairs of the Cartesian product A cross B. Question number 2. Set A is set of x such that x square greater than 4, x less than 2. A belonging to n. A is null set. If x is less than 2 in real numbers, next number will be 1 only. 1 square greater than 4 is false. Therefore, A contains no element. It is a null set. A cross B is a null set. Therefore, n of A cross B will be 0. Then, in the graph, shaded region is A cross B. Therefore, it contains ordered pairs. Here, this is the blue line only. So, here, minus 4, 0, that is point on the x-axis. Then, minus 4, 2, this point. Minus 4, minus 2, point at this place. Then minus 4, minus 1, this point. then minus 4 comma plus 1, this point, all are lying in this shaded line. Then coming to this graph, within the blue shaded region a cross b is there. The points are 2 comma 1, 2 comma 2. 2 is here, then 2 comma 1 will be here, 2 comma 2, 2 comma 3, 2 comma 4. Infinite number of points are there. 2.7 comma 4, 3 comma 3, 2.1 comma 4, all are real numbers. We have just noted 5 ordered pairs. However, there are infinite number of ordered pairs. Question number 4. Write any 5 ordered pairs of Q dash cross Q. Q dash is set of irrational number. Q is set of rational numbers. The 5 ordered pairs are root 2 comma 1, root 2 comma 20, 3 root 3 comma 1.5, pi comma 4, 2 pi comma 4. Question number 5. Write any 5 ordered pairs of Z cross Z. The required ordered pairs are minus 1 comma 1, 2 comma 2, 3 comma 1, minus 3 comma minus 3, 0 comma 0. There are infinite number of ordered pairs possible. In this case also, you can write your own choices. So in functions, some final points. Outside set theory, functions are polynomials in one or more variables. F of x equal to x square plus 2. F of x comma y equal to x plus 2y minus 3. These are examples. F of x equal to square root of x is used widely as function in many calculations. However, in strict set theory, this is not a valid function. A note on domain and nature of functions. Domain of a function is decided by the function only. Function restricts the domain. For example, f of x equal to square root of x is a real valued function, but domain is restricted to positive real numbers only. In the case of f of x equal to 1 by x minus 2 into x minus 7, the domain is R with 2 and 7 excluded. A note on domain and nature of functions continued. In case of composition of functions, the innermost function or first evaluated function decides the domain first, and then the outer functions decide the domain. For example, f of x equal to square root of minus x can have all negative x values, and g of x equal to square root of 1 minus x can also have domain with negative values and numbers in 0, 1 interval. But FOG will be square root of minus square root of 1 minus x. It is undefined for all x. So this function is not real valued at all. A note on range of functions. If we restrict the range or codomain, then some relations can become valid functions. For example, f of x equal to root of x is valid relation but not a valid function, since for each x, two f values exist. If we restrict codomain to positive r, then this will become a valid function. For this function root of x, domain is plus r. Codomain is plus r and minus r. Therefore, this is not a valid function. If we restrict codomain to plus r only, then this will become valid function. However, if we take entire r as the domain, this will not be a function at all, because minus r not valid for x, since this is root of x. A note on composition of functions. If the constituent functions are given as function expressions, then composition of them will be another function expression, and it is no different from functions. If the functions are given as ordered pairs or in table form or in arrow diagram, then composition of functions needs workout. This is the end of lesson 1, relations and functions. Thanks for watching. If you like this video, please subscribe.